So here we have an application. What we're going to do is we want to make a box by taking a 12 by 20 inch piece of cardboard and cutting out equal pieces out of the corners and then folding it up. So this is what we'll end up with after we cut out those corners and fold it up. And the first thing we want to do is find the volume. So we know volume is length times width times height. So once you cut out these corners, this dimension that was 20 inches, we cut out x from this side and x from this side. So now it's going to be 20 minus 2x. Here it was 12, but again, we cut out x from this side and x from this side. So this dimension is now going to be 12 minus 2x. And then the height of the box is that length, whatever we cut out, which was x. So we have 12 minus 2x for one dimension, 20 minus 2x and x, and that's going to be length, width, and height. So length, 20 minus 2x, width, 12 minus 2x, height is just x. And therefore, this is what the volume of the box would be. Now you can multiply that all out, which I don't expect you to do. It's fine just leaving it like that. But the next thing we want to do is find the domain. So what is the possible values that we can cut out of these corners that make sense for this box? And it's going to be, has to be greater than 0, right? Because if it's 0, we haven't cut anything out, so we can't fold up anything to make a box. And this dimension, because this dimension is 12, I have to have it less than 6. Because if it was 6, it would cut this right in half, and again, I couldn't make a box. So our domain for this is going to be between 0 and 6. The use of calculus can help us find out what would be, to maximize the volume, what would be the ideal measurement we'd cut out the corners. And we'll talk about those applications once we actually start using some calculus for it. Okay, so we're back to graphs. And we want to see if something is a function. So the first thing I want to talk about is the vertical line test. The graph is a function if when you draw any vertical line, and the any part is important, right? Because some places you could draw a vertical line and it only hits it in one place, but another one you draw and it hits it in 2 places. So it has to be true for any vertical line. If it hits a graph at most one place, then it is a function. If it hits in 2 or more places, the graph is not a function. So we're going to look at these, and I have them all typed up for you for your notes. But here's our first graph, and then we want to say what the domain and range are as well. So first thing I want to talk about, is it a function? Well, if I draw any vertical line at all, it's only going to hit it in one place. So yes, it's a function. The domain, and we have to assume for these that they just keep going. I couldn't put arrows on the end when I made these graphs, but the domain just goes on forever, so it's all real numbers. And the range, well, it stops there at 0, and then it shoots up from there. So the range for this is greater than or equal to 0. Let me use a different color so I don't make my graph so messy. The second one, again, if I draw any vertical line at all, it's only going to hit it in one place. So it is a function. The domain, again, these have arrows. They just keep going. Unless there's a hard circle, we assume that they keep going. So the domain is all real numbers. And the range, this time the y keeps shooting down there and it keeps going up here. It goes on forever. So the range is also all real numbers. All right, and then this next one.